Okay, so let's begin first. All right, so this part, Lex is here. Let's wait for her. Okay, because Jesse just told me that his computer has some problems, so he will be coming in a little bit late. So anyways, let's start with this picture. Okay, let's understand what this picture is about, right? So what we are doing here, right, the picture that you see right now is actually a zoom in of a portion of the graph, okay? So let me explain on the top. So it's actually a section of this part, okay? We'll look at this graph here. So we have a parabola, sort of like a parabola here. So let's draw with red, right? And then we place a tangent line at xy, right? Point P. Okay, so point P, I will use the green, right? So this is point P. And then we place a tangent line, so it looks like this. Okay, so what the bottom picture is about is actually a little section. Okay, I'll use the purple, okay? So it's zooming in on this portion, okay? Right, zooming in and then give you this picture. Okay, that's why you can see the gap between them. Because if you just look at the purple part, now I lost it. Okay, yeah, if you just look at the purple part, the purple box, there's no gap between the red and the green, right? They are basically they look the same. Okay, if you cover everything else. Okay. Okay, so anyways, so go back to this picture. So just keep that in mind. We are zooming in. That's why the gap is so big, but in reality, they are really close. So here we have a point P on the function f of x. Okay, I'm gonna use the red as well to represent. Okay, and then the green line is the tangent. So the y value for the point P will be there, and that will be f of x, right? Because you plug in the x. And then for point Q, right? Because the point Q is delta x away, right? So let me draw that here. The distance on the x-axis between the 2 points, this is delta x away. So that's why the Q, the x value is x plus delta x. And then to find the y for the point Q, then that will be f of x plus delta x. Okay, so Jesse, since you came in late, okay, I was just saying that the picture that you see on your page is a zoom in section of the purple part. Okay, so yeah, the purple box, do you see the little box, right? We're zooming on that part so that we can see what's happening around point P, okay?
Okay.
So that's why the gap is really big, but in fact, they are really close. Okay, it's very close to point P. So now we are going to talk about the gap here, right? So for tangent line, the green line, the slope, we use dy over dx, right? To represent the slope of tangent. So dy will be the rise over here, over run. So that will be here. Okay, and then for the red one, right? The line for the connecting PQ. Okay, I'm gonna use the red as well. Okay, use dotted line. So we used to call this the secant line, right? Because it's on crossing goes across the graph, right? So then the rise, right? The slope of the red dotted line, the secant line, will be delta y. Okay, and then the run is already down here. We already put it down here, delta x. So both of them are slope, right? Delta y over delta x, dy over dx. One for tangent, one for secant. Any questions so far? Okay, so you can see that the delta x and dx, they are the same size, right? Same value. But then the delta y and dy is different. But if we look at the original graph, right, before zooming in, then you can imagine that you won't be able to tell the difference between the delta y and dy because they are so close. Only when we zoom in, then I can see there is a difference, right? Delta y is longer, dy is shorter, okay? But when it gets really close to point P, they are almost the same. So that's why it's called approximation, okay? Then we can say, right, when delta x is going to 0, right? Meaning the gap between the 2 points, right, P and Q, when they are very, very close, okay? Meaning you are making the triangle really close to point P. We have delta y is almost like dy. Any questions so far? This is the center concept, okay, of this whole approximation. Okay, when we look close to the tangent point, delta y is close to dy. Okay, and then now we apply the formula. Dy we know is f prime of x dx, right? From the before the break, right? We went over this formula. Dy is prime times dx. And delta y is talking about the secant line, right? So we take the y, subtract each other. So it'll be f of x plus delta x minus f of x. Any question here? All right. So we can isolate this part. We're going to isolate this part. So you will get f of x plus delta x.
Wait, sir?
Yes?
Can you explain the f of x times dx part? Like I get the subtracting part. I'm a little confused with the multiplying though.
You mean the f prime of x dx?
Oh yeah, sorry.
Okay, that's from the previous page before the break. Remember we
Oh,
had, right, the formula
yeah.
here?
Yeah. Oh, okay, I see. Yeah, I understand
Okay,
now.
yeah,
Okay,
so
thank you.
dy is prime times dx. That's for the tangent. And then left side is for the secant, okay? And when it's close to point P, they are almost the same. So now we isolate the red. So the red part will be close to f of x plus f prime of x dx. So this is the formula we want to use for this chapter. And what does this formula mean? Okay, let's look at the graph on the right side again. The f of x is the y value, right? Remember that over here, right? I put a red circle, right? The y value from 0 to the top, okay? I'm gonna draw that line, okay? And then dy, right? F of x is this part, right? F of x. Dy is here, f prime dx. And in the picture, it represents this part. Any questions so far? The right-hand side, yeah?
I don't, I'm like a little bit confused because I get the part, where you said like when you zoom, like when it's not zoomed in, it's like super hard to tell, right?
Yeah.
Wait, but for this part, f of x plus f of f prime x dx,
Yeah.
like that part's the dy, right?
f prime dx is dy, yeah.
But it's
This
only
is
like when we
dy.
zoom in that we can tell the difference, right?
Yeah.
Okay. Otherwise, it's like the same thing, right?
Otherwise, yeah, otherwise they look very close.
Okay, okay.
Yeah, so
Thank you.
that's why at the beginning we have delta y close to dy,
Okay.
right?
Yeah. Thank
Yeah,
you.
okay. So now I'm just trying to show you the idea differently, okay? Hopefully I don't confuse you more, okay? So the f of x is talking about from 0, right? The height, right? F of x means the y. So the y from 0 to point P, right? It's this part. We are looking at the y-axis right now. And then the dy is the green part, right? F of x is here. So if you add those two together, it will be almost the same, right? Almost the same as f of x plus delta x, which is this part. I'm gonna draw on the left side. So this part is the f of x plus delta x. Right now, it looks like a big gap, right? Right, there's a big gap in between, but that's only because we zoom in. But if we zoom out, then those two lines are almost the same. Okay, that's the idea. Okay, just trying to show you different way to look at the formula. Okay, so that you can remember the formula more easily. Any question? Okay, so right now you can see the gap only because we zoomed in. Otherwise, if you look at this, there's no gap in between. Okay, the inside the purple box, right? The red and the green, they are just like touching each other. Okay, so if there's no question, let's practice some easy question first. Okay, just learn to think about delta y and dy separately. Okay, and then we're gonna draw a picture, right? Draw the diagram here, and then find the value of delta y dy, and then show how they are different as x changes. Okay, here the x, these are x value for question A. Okay, x is changing from 2 to 2.1. Okay, so this is the x, this is the x plus delta x, right? It changes, goes out a little bit bigger. Now for question B, it also goes up, right? But it doesn't goes up as big as the question A, right? Goes up just tiny little bit, okay? And then we'll compare their value for delta y and dy. Okay, so I will go over question A together. To find delta y, right, you look at the formula, right? To find the delta y, you take the y of each one, right? So it'll be f of something minus f of something. Okay, which one should go in first? Anyone?
F of x plus delta x first.
So it will be 2.1, right? And then the other one will be the f of 2. Okay, and then we will plug into the function. So everyone take out your calculator. Okay,
Wait,
so
sorry,
yeah,
sir.
yeah.
I'm a little confused with the because f of x plus delta x, x is 2, right? And then
Yep.
oh, thank you.
So what's the delta x?
0.1.
Yes, it's adding by a little bit. Okay, you
Yeah,
can put that on the
thank you.
side. Okay, so plug into the function. Okay, and the function is right up here. Okay, the red underline. And then please calculate each value. Raise your hand if you get them. Okay, and subtract them. Please raise your hand if you found the values. Okay, Joan, what do you have for f of 2.1?
I got 3.861.
Okay, and f of 2?
3.
3. Okay, so if we subtract, it will be 0.861. Carrie, do you have the same?
Yes.
Yeah, okay, thank you. Now let's do dy. So dy will be the same way that we do before on the last page. Okay? So I'll let you try that by yourself. If you have
Wait,
any
sir.
question, let me know. Yeah.
How would we draw for like when they say draw a diagram? Do
We'll
we
draw
like?
it together. We'll draw it together. Okay.
Okay,
Let's
okay.
find the value first, and I'll explain. Okay. The formula is f prime and then dx, right? F prime is 3x squared minus 4. Okay. And then times it by dx. So anybody has trouble subbing in? We need to get a value here. What's the x value that we should sub in? Leon?
2.01.
You should be subbing in 2. Okay, x should be the 2 because it's changing from 2. Okay, look at the picture, right? X is at 2. 2 is where you put the tangent point. And what about the value for dx? What value for dx do you use, Carrie?
I'm not sure.
Not sure. Anyone? Anyone else? What value should we put for dx?
Is it 0.861?
0.861. No, 0.861 is delta y.
Oh,
My
wait.
question is dx.
Whoops.
Isn't it delta x like 0.1?
Yes, 0.1, right? As we mentioned before, the delta x and dx are the same, right? The only difference is the delta y and dy. They are close, okay? They are not the same. They are close to each other. Okay, so just a little review, right? What we did before. So 0.1 should be here, right? It's same as dx. And then you sub in the 2.
So that will be what?
12 minus 4, 8. So answer is 0.8. Okay, so you can see that delta y is 0.861, dy is 0.8. They are close, okay? So what does it mean on the graph? Okay, let's quickly draw that on the side.
Wait, sir.
Yes?
How did we know for? Okay, thank you. Yeah, I just saw the x plus delta x and then yeah.
Okay. Yeah, okay. All right, so we want to put, so this is a cubic graph, okay? We're just, we have, okay, 2 is at 3, right? So we just draw at 2, and then here's a 3. We are zooming in, okay? I know the numbers are very tiny, right? 0.86, the decimals. So I'm just gonna zoom in. So you have a point here, here's a curve, okay? Something like that. And then you want to, the other x, right, is at 2.1. So because zooming in so you can see better, so my 2.1, I will put it here, okay? But in fact, they should be really close, right? But since we're zooming in, it'll be here. and then your 3.861 will be here. We're using number, right? So it can help you understand the picture again, right? Even better. So we have a tangent line, which is going to be placed at 3. Okay? So what's happening here? The 0.86 is talking about the y value, the delta y. So it's talking about this part. This part is the delta y. 0.861. Okay? And then for the 0.8, it's talking about the slope of the tangent line. Okay, between the same 2 points. Okay, I put it a little bit split up, but in fact they should be on top of each other. Okay, so your dy is talking about this section. Okay, so if I put it side by side, it will be this way. Dy. And that's 0.8. Okay, so that's what it means. I'm just talking about the same thing, like repeat again, but with numbers this time. Okay, so as you can see, delta y, it will be a little bit bigger than the dy, but they are close, especially if we zoom out, right? If you see, I make the numbers very small, right? The picture very small, you can almost, right, unable to tell which one is longer. They're almost the same length, delta y and dy. Okay, only when you see zoom in, then you can see a big gap. That's the idea. Okay, so I'd like you to try one more time. Okay, for question B, do the same thing and then draw the picture by yourself. All right, so same values here at 2, but then your delta x is different now. All right, so once you finish the picture, the delta y dy, you can raise your hand. Okay. Try to place the numbers into the picture, okay? It can help you understand the formula. Okay, f of 2.01 minus f of 2. For dy is the same formula, but then you'll be subbing in different values. I'll just check the final number, okay? Please raise your hand. So this time you should get something even closer, okay? Your delta y and dy. Think about it, right? Instead of 2.1, we are shifting to 2.01, right? 2.01, oops, 2.01 will be like, okay, we are all done, right? Okay, let me draw this again. Okay, 2.01 will be like somewhere here, right? So it's really, really close. Okay, so what's the answer for delta y here? Joan?
I got 0.080601.
0601, like that?
Yeah.
Okay. And Jeffy, what about your dy?
My dy is 0.08.
Okay. Right, so they are even closer than before, right? Before the difference was 0.061. This time, if you subtract, you get 0.000601, right? So they are even closer to each other. So that's why we can use this to approximate. So the smaller, right, the concept you need to remember is the smaller the delta x, the more accurate your estimate is, okay? The delta y will be even closer to dy, right? So the two example is just trying to demonstrate that it works, okay? And then here, the next line is to apply the formula, right? We isolate the y value. So on the next page, we are going to use this formula to estimate, right? Our goal is try to find this value, okay? This one, the y values. The 3.861 is the f of x plus delta x. This is our goal, right? We're trying to estimate the 3.861 using the dy, right? So as we can see here, right, this is our goal. We want to find this value, the red line, the long red line, using f of x plus dy. Okay, so let's try with an example now. We'll look at next page, page 114. So use differentials to approximate this value, okay? And we're going to find out whether the estimate that you get is overestimate, means too high, or too low, underestimate, okay? So first thing, you need to break this up into, well, first you need to identify the function, okay? So this looks like we are subbing in 10,008 into the fourth root function, right? So our f of x should be fourth root of x, right? So our goal is try to estimate what is f of 10,008, right? This is our goal. Any questions so far?
Yeah. How come like our function isn't just f of x equals the fourth root of 10,008?
Function, it should be able to take value, right?
It should have variables,
Oh, okay.
right? So we need to have input and output, right? If you say it's fourth root of 10,008, then there's no x.
Oh, okay.
Right? It's a constant. Yeah.
Okay.
Okay. So so we can use this function to estimate anything, right? So the question wants us to approximate, right? Approximate this one. So same as finding what is f of 10,008 now, right? F of 10,008 means you sub in 10,008 into the fourth root. Okay, so by looking at the formula we have above, right, on the previous page, okay, I hope by now that formula should be in your head, right? Because we look at it many times, right, using pictures. So let's write it on the top anyway, right? Even though you memorized it. So close to the y plus dy, right? Okay, so I first need to split it into two parts. And remember, delta x has to be something small, right? So the question that we want to find, I can split the inside into 10,000 plus an 8, right? Because 8 compared to 10,000 is quite small, right? It's just a little difference. then it will be close to f of 10,000, right? I'm just following the formula, plus f prime of 10,000 times dx. What's the dx here?
8?
Yes, dx is same as delta x. Okay, and remember Carrie was asking that, I asked Carrie about it, right? So delta x and dx is the same thing. So after this, we just calculate each part, right? F of 10,000. And also the reason why I choose to split it with 10,008 instead of 10,007 and plus 1, right? Why not choose the other one?
Because this one's like has a bunch of zeros, so it's just easier to do.
That's right. Yeah, we choose it so then we can do it without the calculator help at all, right? 10,000, I can sub it into the fourth row, right? And I can figure out very quickly. And the answer for that should be what? What's the fourth row of 10,000?
Oh, 10.
10.
So it'll be 10. And then the next part is you need to do the prime, right? So we do the prime on the side. It will be 1 over 4 x to the negative 3 over 4. Okay, so we plug it in. That will be like fourth root of 10,000 and then cube, right? Times it by 8. Anyone has questions so far? Okay, and then continue. 10 plus fourth root of 10,000 is 10, right? 10 cube is 1,000. So if we multiply, it will be 8 over 4,000. Are we good? We can reduce it. So 10 plus, that'll be 1, that'll be 500. 1 over 500. So close to 10 and 1 over 500. Now let's turn that into decimal, right? 1 divided by 500, what is it?
0.002.
Yep, so 10.002. So this is the approximate answer for this thing, okay? So this is the approximation. Okay, and then let's check, compare with the actual one. To get the actual, you use the calculator, okay? So we plug it into the calculator, fourth root of 10,008. Can you try it? Fourth root of 10,008.
It's like 10.001994.
Yeah, so which is pretty good, right? We did it without any calculator help at all, right? So that's one of the application, okay? Even though you don't use this for grocery shopping. So, but anyway, right? You can use it to approximate, okay? So this is actual. So I'd like you to try, okay? Try a question down here. We'll just pick one. And let's do D. Actually not D, okay? Because we didn't learn the derivative for that one. Okay, let's do C, okay? Question C. Follow the same thing, right? First, you got to identify the function and then think about f of what? What's the input that you're looking for, okay? After that, it just step by step follow the formula. Okay, so can you let me know, raise your hand if you got the first two things, right? The function and the f of something. How about the rest of you? You haven't figured out what's the function here? Anyone has trouble figuring out the function? Please raise your hand if you got the function and the input. Okay, Joan, what's your function?
I did 1 over x.
Okay, and what was your input then?
101.
101, yeah, that will work, okay. And before you guys continue, all right, so we forgot to talk about overestimate or underestimate, okay? So let's go back up a bit. So this one, we got approximation, that's 0.002, and the actual one is 0.001994, right? So is this one over or under?
Over?
Yeah, over. So usually the question, they won't ask you to go through all this and check, right? That will be too easy. So they will ask, can you find out over or under without actually estimating it? Okay, then that will be the harder part. So I want to know that before without calculating the estimation. So the way is to look at the picture. That's why we spend so much time talking about the graph. Okay, so if we try to draw this one again, okay, so this is fourth root. Okay, so basically if you need to answer this without estimating, you need to know the graph. The fourth root, if you don't know the graph, you can do table of value, right? You can plug in 0, you get 0, right? And then you plug in 1 will be 1, right? And then slowly gets higher, kind of like, looks like a square root function. And the location that you place the tangent, where do you place the tangent? What value?
Like where do you put the
What's the
tangent point?
tangent point? Yeah, tangent point. What's the x value?
10,008.
Actually, it should be just 10,000. Right? You look at here because it's f prime of 10,000. Okay, so that's where you put the tangent, and then so let's zoom in here, 10,000, and you put the tangent there. So what's actually happening here? You are trying to use the green line to estimate the y value at 10,008. I'm gonna pretend 10,008 is a little bit further away, right? In fact, it should be really close. Okay, so you are trying to get this value. That's the question mark. Okay, the y value for the red dot. That's what we are doing, right? 10,008 inside the on the function, but then we are using the green line to estimate. So in fact, what we found is this part. The answer that you get, the 10.002, is this one. Okay, and the actual number that you get is 10.001994, right? That's the question mark. So you can see that from the graph, the point, the green dot is above the red dot. So that's why it gives you an overestimate. Does that make sense? Okay, so you can tell without doing any estimation just by looking at where the tangent line is, right? If the tangent line has to be higher, right, above the graph, you know already it's going to be overestimate. Okay, so you can write that down, estimate, because tangent is above the function. Okay, so if the graph looks like this and then tangent line is down here, then it will be underestimate, right? Without doing any estimation. Okay, so it could be either above or below. So I'll let you try this as well, right? You can continue with this now. Okay, you can do the split. And then do the rest. And then let me know whether this one is over or underestimate, okay? So once you finish, please raise your hand. Anyone has questions?
Wait, Jason, I have a question about like when we graph.
Yeah.
So for C, like the number, wait, I'll just see what you do and then see if like I kind of understand. Never mind.
Okay. Okay. Okay, so for this one, how do we split up the numbers? Joan?
I did 100 plus 1.
Okay, plus 1. Okay, so we just plug it in, f of 100. And then Leon, how do you carry on? Plus what?
What was the question?
After this, what do we need to plus?
F prime 100 times 1.
Yeah, times it by 1. Okay. So if you get a final answer, please raise your hand. We need to prime this. F prime should be okay. Jeffy, what's F prime?
Is it negative x?
Negative x. That's it.
I think so. Oh, wait. Over, wait. Is it over x squared?
I'm gonna erase. Can you tell me what to write? What's F prime?
I think I did mine wrong, but because you can change 1 over x to x over, or no, x to -1, right?
And then
So, oh, wait. So it'd be negative x to -2 to power -2.
yeah,
Okay,
which
yeah.
is same as what over what?
So it'd be -1 over x squared.
Yeah. Okay. So you gotta use that for your F prime. Okay. All right. And then Lex, what's F100?
F100 is 1 over 100.
Yeah. And then Carrie, what's F prime of 100?
-1 over 100 squared.
Yeah. So 100 square will be something like this. So that will be what? If we add them up, what's the final answer, Leon?
I got 0.0099.
99. Emily, how about you? Do you have an answer?
I have the same thing.
Same thing. Okay. So let's check with the actual. Okay. First of all, right, before we check with the actual, is this one over or underestimate?
Under.
Under. Okay. How do we graph the function here? Do you remember what 1 over x looks like? It has asymptote.
Yeah, like that.
Yeah. Right, and then we are placing the tangent at 100. Right, we place a tangent here. You can see that the tangent line is underneath the function around 100, right, at that point. So you know it's going to be underestimate, right, underestimate. Okay, and then let's check the actual answer. 1 over 101. What does it equal?
It's
Joe?
0.0099 repeating.
0.0099.
And then repeating.
Repeating 99?
No, the 0099, all of it.
Oh, okay. Let's see. So 0099. Okay, so that's pretty close. And then we got an underestimate, right? Because this one, the estimate that we got is 0.00990000, right? So which is smaller than the actual one. Okay, so
Wait, Jason.
Yeah.
I have a question about the graphing.
Yeah.
Because we know 1 over, like, when we guess 1 over, oh, no. Oh, okay. We just split the 101 into the 100, right? That's what it is.
Yeah.
Okay, thank you.
Okay, so the actual place that you're looking for is 101. So 101, let's say here, right? So you have a green dot, right? Let's zoom in. Green dot is here, which is lower than the red dot at 101. Okay, so you get an underestimate. Okay, I want to squeeze the last little bit, okay, of this application. Go to page 116, please. So this is basically the same old stuff, but they try to word it differently, okay? So this is called linearization of the function. So that's what we've been doing actually, okay? They just put it separately and call it linearization, because if you look at here, right? If we just look at the zoom in section, right? Without zooming in, I can see that, okay, the red graph is a curve, right? It's getting lower and lower. But if I zoom in, right, and then I just look at the green and the red, right? If somebody who's not here today, right, and then just walk in just now, right, and look at these two lines, and then I ask, which one is the curved line? Which one is the straight line, right? They won't be able to tell because they both look like straight lines. So this is called linearization. We make the graph look like a straight line. So at 100, right, when it's very close to x equal to 100, the function, the red one, is the same as the green one. Okay, so at that place, it's called, we made the function look, has an equation of a tangent line. So in other words, right, put it in short, it's just when we say we want to linearize the function, is just finding the tangent line at a point, and which is something you've been doing for the past couple months, not couple months, 1 month, right? Okay, so linearization, let's put that in simple words, okay? Equation of tangent. They just use a different word to make it sound very fancy, okay? Equation of tangent to the function, which is called linearization of the function. Make sense? Okay, so let's look at the definition then, okay? Maybe now it will make more sense, okay? Given a function f of x, we can place a tangent line at any point x equal 8, right? That part is easy. And then use the equation of tangent, which is linear, to approximate any value near the tangent point. Then this procedure is called linearization of the function. We use linear line to approximate the value, okay? So question, here's the example we have is f of x equal to root x plus 2. Let's draw it out. x plus 2, if you remember transformation, right? Compared to this one, what's the story for y equal root x
You
plus 2?
move to the left.
Yep, move to the left by 2. So let's graph it out, right? And then it goes this way. We want to find the linearization at a equal to 1. A is the x value, okay? So at a equal to 1. Okay, so we are going to place the tangent here. Right, when it's really close to a, red and green, no difference. Okay, and then after that, we want to use it to approximate the value of these two. Okay, so don't worry about the linearization, right? Just find the equation of tangent. And then we'll go from there. Okay, so once you find the equation of tangent, please raise your hand.
Wait, equation of tangent is just like the thing we just did, right?
Yeah, you've been doing it since a long time ago.
Wait, okay, I'm kind of confused. Can you re-explain what equation of tangent is?
Okay, then we need to go back then.
Oh, sorry. Thank you.
It's okay. Equation of tangent is a straight line. To find straight line, you need to know two things. Which two things?
Domain.
Oh, straight line. Equation of a line. What do you need to know?
Oh, the intercepts. The slope.
You need to know the slope and what else do you need to know?
the constant.
A point. You need a point.
A point.
So you can write what form?
Slope intercept.
Slope
point.
Yes. Point
Oh my
slope point.
gosh.
Okay. Yeah, this is the very beginning thing that we learn here. Like for example here. Yeah, equation of tangent. Remember this one? This is what, page 31?
Oh, wait, this is called equation of tangent?
Equation of tangent will be like, okay, this will be more complete. Right? Page 27.
Okay.
We have three equations, right? We have point slope form, general form, slope y intercept form.
Oh yeah.
Yeah, so you got to find a point. You got to have a point. You got to know the slope. And to find the slope, you use prime.
Oh. Okay.
Okay?
Kinda, yeah.
Yeah, you learn all the hard stuff. Now you forgot the easy things.
Yeah.
Yeah, okay.
My memory's not like that.
No, it's okay. Yeah, I know this happened when you learn something too advanced. Now you know how to optimize, you know how to get related rates. You forgot how to get the equation with tangent. Okay, let's go back to that page right here. All right, so we need to know the slope. Okay, I want to find the equation of tangent at 1, all right? One what? What's the y value for that point?
√3.
Yeah, √3, right? So you see, we have a point. Please get the slope and write out the point slope form. Okay, raise your hand once you get the point slope form.
Wait, did I have to do limit for it, or can I just use
No
the?
limit. Use the prime. That's why
okay.
the power rule, product rule, right?
Wait, I'm kind of confused though.
Which part?
This sounds kind of stupid, but can I just use like -2, 0, and 1 √3 to find the slope?
Negative. Say that again. Negative what?
-2, 0,
Oh,
and
you mean this
1.
point?
Yeah,
And 1 √3?
yeah, to find the slope.
then that will be the slope of the secant line, right? It's not the tangent line. We're finding
Oh.
the equation of the green line,
Oh, okay.
right? How many of you doesn't know how to find equation of tangent? Can you raise your hand? Okay. Only raise your hand if you don't know how to find equation of tangent.
I kind of half remember,
Okay.
but I also don't remember.
Wait, I don't
Okay.
remember if when you say prime, like, do we use the f of x plus h stuff, or?
That's using limits. Yeah,
Oh.
using limits is the slow way, right? And then later on, we learn the power rule, right? Quotient
Yeah.
rule, right? So that's the fast way. Okay, looks like a lot of you forgot how to get equation of tangent. Let's go over it then, okay? So first, we need to know a point, right? The point we have is 1√3, right? Now we need to get the slope. We want to find the slope. Slope means prime, right? Slope of tangent is prime. Slope at where?
1.
1. And how do we find the prime at 1? What do we need to do then?
Oh, you wait. You do chain rule to the root x plus 2, right?
Yeah, you got to prime it, right?
Okay.
To find the slope at any point, right? So what's the prime of our function?
It's 1 over 2 x root x plus 2.
To the,
To the negative 1 over 2.
yeah. Right, so this represents the slope. Remember, I keep asking you guys to repeat, right? Slope at any x, right? When we first learned it. And then we can use that to find the slope at any place. Here we want to find the slope at 1. So what's the slope at 1 now? 1 over 2, 1 plus 2 to the negative half, which is what? 1 over 2
root 3.
root 3.
And then do we rationalize?
If you want, it doesn't matter. We can leave it like this, right? Now let's write out our equation of tangent. Point slope form. Right, this is the slope. So point slope form, what does it look like?
Oh, do you want someone to do you want to answer, or
Yeah,
was
yeah, I
that
want to answer point slope form.
I got y minus root 3.
Equal?
I did root 3 over 6, like I rationalized it.
Okay, so I will keep it the same formula and then?
X minus 1 in
Yeah.
brackets.
Yeah. Okay, I hope this is not like a stranger to you, you guys. Okay, I know it's been a while, but this should be the minimum thing that you have to know, okay? Finding equation of tangent. Okay, so this represents the equation of this line. And then we want to use this, so of course you can move it, right? Isolate the y and then I put root 3 plus 1 over 2 root 3 x minus 1. Before we move on, let's take a look at this equation. Does this look like something above? Does it look something similar to this? Right, or the thing up at the top?
Yeah.
Right,
A little bit.
why I put a star? Right, it looks just like that. Right, the left side is the y, and then this one, right, y equal to f of 1, right, plus f prime of 1, and then x minus 1. X minus 1 is like the dx, or the delta x, right? Compare with the compare with the formula that we had before. F prime of x plus delta x close to f of x plus f prime of x dx. Try to compare these two. Right? They look very similar. Dx is x minus 1, right? Because dx means difference. So you subtract them, right? F prime of x is f prime of 1. Okay, so it actually came up with the same thing. It's just this is equation of tangent. So we want to use this to estimate 2.98. Okay, so let's write it here. The first one is 2.98. So you look at the picture. If I want to get 2.98, and then you look at the function, what should the x value be? What x? If I put it in, yeah?
2.98.
If I
Wait.
put 2.98, would you get square root of 2.98?
Oh, no.
What would you put in?
0.98.
0.98, right? Because the function that we are using is square root of x plus 2. Okay, so this one is close to f of, or okay, let's not use f, okay? Because f is the red one, okay? The one that's linearized, okay? This is the equation of tangent, right? So I'm using the green. This one is called the L of x. L stands for linearized, okay? Which you can think of it as the equation of tangent line, okay? So square root of 2.98 will be close to L of 0.98. Does that make sense? Which is on the left side of 1. Okay, 0.98 will be here. Right, the x value, it's on the left side of 1. So you plug it in into the green line, it will give you this green dot, right? It will give you this y, right? And then that will be close to the actual one that you want to get. So this one you are doing an overestimate. Any question?
Wait, when it tells us to approximate the values of the stuff, do we have to find like the actual number or no?
Yeah, you need to find the actual number. Okay,
Oh,
so
nice.
now you plug it in. Okay, so you will plug it into your equation of tangent, right? So it'll be root 3 plus 1 over 2 root 3 times 0.98 minus 1. Okay, so everybody please type it in and raise your hand if you get an answer here. Okay, Carrie, what do you have?
I got 1.726.
726. Okay. Jeffy, do you have the same?
Yep, same thing.
Right. So 1.726 should be smaller than the actual answer. Sorry, bigger than the actual answer, right? Because we're doing overestimating here. Okay, what about the other one? Square root of 3.02. This one will be close to L of what?
1.02.
Yeah, 1.02. Okay, so it's like you plug into 1.02. So which will be on the right side, right? Right side 1. And then the red will be down here. The red is the actual answer. The green is the estimating answer, right? Because it's on the tangent line. So also please plug it in. Okay, let's try one more time. Raise your hand if you get that answer. Okay, Emily, do you have the final result?
Yeah, I have 1.7378.
378. Okay. Joan, how about you?
I got the same thing.
Yeah, okay. Okay, so that should be it, all right? So that's how you do linearization. And if you have questions, you can either rewatch the video, okay, or stay after class, okay? I'll see you next week.
Thank you, sir.
Bye.
Thank you,
You're
Jason.
welcome, everyone. Bye-bye. Good night.
Bye.
Bye.
Jason, I have a question.
Yep. Yep. What's
Is
the
this
question?
course AP calculus or just calculus?
AP calculus.
Oh, okay, thank you.
Yeah, and it's the AB. AP has 2 parts, right?
Oh, okay, okay.
Yeah. Okay.